I welcome you all in this freshman course in mathematics for natural science. This video is about compound propositions, and in this video we are going to discuss compound proposition, tautology, contradiction, equivalent propositions, and converse, inverse, and contrapositive. So let's start with compound proposition or complex proposition. Any two propositions joined with the logical connectives are called compound propositions. They are denoted by the capital letters PQRS or P1, P2, P3, P4. Here we have considered three compound propositions P1, P2 and P3. In the first compound proposition, this is a connection of two propositions P and negation of Q with the logical connective implication. While in the second compound proposition, we have two propositions P and Q, and there are two logical connectives, implication and conjunction. While in the third compound proposition, we have three propositions PQR. They are joined with the disjunction logical connective, by implication and conjunction. So these type of propositions are called compound proposition. Now how to write a truth table of a compound proposition. Here I have taken the example of P implies negation of Q. This is a compound proposition. Here we have two propositions P and Q, so we have four possible combinations. As both P and Q are true, P true, Q false, P false, Q true, or both P and Q are false. So first of all we will write the negation of Q. So if T is true, if Q is true, so its negation will be false. For false, it's true. Similarly, this one is false and this one is true. Now we have to write P implies negation of Q, means true implies false. As we know that for any two proposition P implication Q, this is false if and only if the first one is true and second one is false. So true implies false is false, true implies true is true, false implies false is also true, false implies true is true. So this is the truth table of the compound proposition P implies negation of Q. Let's take one more example. P implies Q and Q implies P. So first of all, you'll find P implies Q. As we know, P implies Q is false if the first proposition P is true and Q is false. So true implies true is true, true implies false is false, false implies true is true, false implies false is true. Now Q implies P. Q implies P will be false if the first proposition, that is Q, this is true and this one is false. So true implies true is true, false implies true is true, true implies false is false, false implies false is true. Now we have to join them with the conjunction, that is called AND. So true and true is true, false and true is false, true and false is false, true and true is true. This is the truth table of the compound proposition Q. Now tautology. A compound proposition is said to be a tautology if all its truth values are true for all possible combinations. For example, this compound proposition is a tautology. P and Q implies P. Let's prove it. Since there are only two propositions P and Q, so we have four cases. P, Q both are true, P true, Q false, P false, Q true, or both P and Q are false. So first of all, we will write P and Q. True and true is true, true and false is false, false and true is false, false and false is false. Now we have to take implication of second column, third column and second column. True implies true is true, false implies false is again true, false implies true is true, and false implies false is true. As you can see here, the truth values of this compound proposition is always true. So this compound proposition is called tautology. Now contradiction is a compound proposition whose all truth values are false for all possible combinations. Here I have taken the compound proposition Q. This is a contradiction. Let us prove it. Since the compound proposition Q contains only two propositions P and Q, so we have four possibilities. First of all, find out the negation of P and negation of Q. So if P is true, negation of P is false. If it is false, so this one is true. Now negation of Q. If Q is true, this is false. If Q is false, negation of Q true. Similarly, this is false, this one is true. Now P or Q, true or true is true, true or false is true, false or true is true, false or false is false. Now P or Q and negation of P means the fifth column and the third column. So true and false is false, true and false is false, true and true is true, false and true is false. Again take the conjunction of the sixth column with the fourth column. So false and false is false, false and true is again false, true and false is false, false and true is false. Since all truth values of this compound proposition Q, this is RQ, are false, so we can say that the compound proposition Q is a contradiction. Any two compound propositions P and Q are said to be equivalent if they have same truth values for all possible combinations, and they are denoted as P equivalent to Q. For example, P implies Q and negation of Q implies negation of P are equivalent propositions. Let us prove it. P implies Q. True implies true is true. True implies false is false. False implies true is true. False implies false is again true. Negation of Q is false, true, false, true. Negation of P is false, false, true, true. Now negation of Q implies negation of P. False implies false, true. True implies false, false. False implies true, true. True implies true, true. You can see here the truth values of P and truth values of Q are same for each combination. For first combination, P is true, Q is also true. For the second combination, P is false, Q is false. For third combination, P is true, Q is true. For fourth combination, P is true, Q is true. So P and Q are equivalent propositions. Now come to converse, inverse and contrapositive. For any given conditional statement P and Q, its converse is defined as Q implies P. Inverse is negation of P implies negation of Q, and contrapositive is negation of Q implies negation of P. Let's take one example. Suppose we have any two propositions P and Q defined as P, Earth is a planet, and Q, there is a life on Earth. So the conditional statement P implies Q is defined as if Earth is a planet, then there is life on Earth. Its converse will be given by Q implies P, means if there is life on Earth, then Earth is a planet. And inverse will be given by negation of P implies negation of Q, that is, if Earth is not a planet, then there is no life on Earth. And contrapositive will be given by negation of Q implies negation of P, means if there is no life on Earth, then Earth is not a planet. Thanks for watching the video.